Hello, students. Welcome back to Unit 8 Notes, Section 12.3. We'll start by, again, you can pause the video right now if you want to try the warm-up on your own. I will begin answering questions. So identify the following and circle P at the right. Now there could be multiple answers, so I'm just going to do one of them to save time, but we have a semicircle. We'll call that QRS, so semicircle QRS. We have a minor arc. How about ST? Because it's less than 180, where a semicircle was 180. Remember, I used 3 letters, not 2, to tell direction. QRS said go around in this direction, not around in this direction. All right. A major arc, I'm going to do QTR because, again, I'm going to go past the 180 a little bit further. Whatever that is more than the 180. So we're going to have QTR. And then a central angle, I'm going to label, how about angle SPR? Now, central angles can be more than 180 degrees. But in this case, I chose an acute central angle. All right, find the measure of each arc in circle P. So I'm going to label this, and I'm going to do a little bit of, I'm going to do a little bit of algebra. Let's see, 145, I'm going to take that away from 180, 35 degrees. So I have 35 here and 35 here. And this one will be 145. This one will be 86. And lastly, I'll do 180 take away 86. And I will get 94 degrees for this last one. So 94 and 94. Like I said, sometimes it's just easier labeling all pieces of the circle, the circle's arcs measure, and then answering the question. So we're going to say the measure of ST, the measure of STQ, the measure of RST, and the measure of TQ. All right, ST appears to be 86. STQ is a semicircle. Yeah, STQ. That's 180. I'm using the angle, the arc addition postulate for that. RST is going to be 35 plus 86. So the measure of RST is 8, 9, 10, 11, 121 degrees, I believe. Let me just check my work. Yep. And measure of TQ is 94 degrees. All right. So now we're talking about inscribed angles. They're different than the central. So let's take a look. We have a whole bunch of central angles here. TPQ, QPR, RPS, and SPT. The difference between a central angle and an inscribed one is this. Central angles are in the center. Inscribed are fully inscribed within a circle. So they don't go from T to P and S to P. They go from T to the other side of the circle and S to the other side of the circle. And they have special properties. So we want to be careful when we're working with central angles that we don't confuse them with inscribed angles. Here's what's really cool. I'm going to focus on this problem that we have here. So for TS, if I go from T all the way over to Q, and I go from S all the way over to Q, that would be an inscribed angle TQS. TQS is actually going to be half of, it's going to be half of 86 degrees. So angle Q will be 46. And that's what our lesson's about today. So I'm not going to leave it here. I'm going to focus more on it in the examples that will follow. But I just want to show you kind of how it's related to what we just did in the last in section 10.6. So inscribed angle, the arc that it intercepts is called the intercepted arc. And we're going to find the measures of them. So finding the measure of an inscribed angle. So here is the intercepted arc. It's already labeled AB is the intercepted arc. The inscribed angle is ACB. And I'm going to make up a guess. Let's say the angle, let's say the arc is, I don't know, this looks maybe to be a 50-degree measure. Again, I'm totally approximating. I have no idea. What I do know is that the angle here is going to be 25 degrees. So for inscribed angles, they are always half of the arc they intercept. Or I can reverse that and say the arc that's intercepted by the inscribed angle is always double the angle. And that leads us to the inscribed angle theorem. So the measure of an inscribed angle is half the measure of its intercepted arc. We could also write this down, that 2 measures of angle B is equal to 1 measure of arc AC. Oops. For me, it's always easier to double something than it is to find half of something. But in this case, you won't have a choice. If you're given the arc itself, you're going to have to find half of it to find the angle. If you're given the angle, you're going to have to double it to find the arc. All right. Now, here's a corollary to that. So 2 inscribed angles that intercept the same arc are congruent. What does that look like? Well, I'm going to draw it off to the side. So I'm going to, it says 2 inscribed angles that intercept the same arc are congruent. So here's a circle. I'm definitely going to run out of room here, but I'm going to try my best. Here is an intercepted arc. Let's name the arc AB. Think about whatever the measure of AB might be. Maybe I should put a number on it. I'll say that it's, why not? Let's keep it 50 degrees. So here's arc AB. It's 50. And here's angle ARB. So angle RB will be 25 degrees. Okay, that's cool, right? But let's say that we have a totally separate thing happening. Let's go with AZB. Okay, AZB. Well, because the arc is also 50, this angle is also 25 degrees. So what do I know? I know that ARB is congruent to AZB because they both intercept arc AB. And so this intercepted arc right here is the same arc for both. And that's the corollary. So 2 inscribed angles that intercept the same arc are congruent. That's the proof for that one. Now the next one, an angle inscribed in a semicircle is a right angle. Okay, an angle inscribed in a semicircle is a right angle. So let's make another circle. You know what? This was a decent size circle, so I'm going to just copy that. And I'm going to clean it up. Let's do that, and I'll get rid of all of this. Okay, we have let's put a semicircle through this. This is not in a good spot. I'll do number 2 off to this side. And 1. I keep doing what I don't want to do. Let's change this one pink, and I will circle this one so we know that the pink one is off to the right. There we go. That's number 1. This is number 2. So here we're back to the grind now. Let's make this a semicircle. Now that we have a semicircle, think about how much this arc is. This arc is 180 degrees, right? And this arc is 180 degrees below. But I'm going to leave this off for a second. Let's inscribe this now. So it's saying, label this one A, label this one B, and we now are going to inscribe this. So right there, we inscribed it. Let's call it AQB. Well, if that arc is 180 degrees, then in this case, any inscribed semicircle that's happening here is going to be a 90-degree angle. It's always going to be a right angle. Doesn't matter where you put it either. So let me do another one. I'll draw in a LB. Here's L. L will also be a 90-degree angle. So it doesn't matter where along the circle that happens. If it's a semicircle, then you'll have that right angle that will occur because 180, half of that is 90. The last one, the opposite angles of a quadrilateral inscribed in a circle are supplementary. Because a quadrilateral can have 4 different size legs, right? So here, let me do this one, purple. Let's say I have a circle. Oh, that's an oval. Oh, ellipse. All right, here's a circle. Think about if I split this apart. Let's say I were to split it like this. It's not a diameter. What I know is that this angle inscribed here and that this angle inscribed here would work off of the opposite arcs. So think about this. This arc here is correlated to this angle, so it's half of it. And then this arc here, whoops, I meant to highlight. This arc here is correlated to this angle. So if the collective arcs together, the blue arc I drew in and the orange, sorry, that I highlighted, those arcs together, if those arcs add up to 360, then when you find half of the blue one and you find half of the orange one, you will then have half of 360, which is 180. And that's truly what this is saying. It's saying that if I erase all of this junk here and I erase that this random quadrilateral that this angle A and this angle B have to add up to 180 degrees. Just because I'm utilizing the entire arc around the entire circle, which is 360. Find half of 360, it's 180. So however that breaks out, it might be, I don't know, 200 and 160. So half of that is 180, which is 180. So A plus B will add up to 180, and let's do, and then C and D. So measure of angle C plus measure of angle D will also add up to 180. It will always work because it's literally the other half of the arc that you're talking about when you look across for the inscribed, the intercepted arc and the inscribed angle. Okay, I hope that wasn't too confusing. Together, the quadrilateral will always add to 360. Again, it doesn't have to be perfect in any way. I think I drew this quadrilateral with 4 different length sides. It's fully inscribed, but across from it will always be, each angle across will add up to 180. And with that same notion, it doesn't matter if something's inscribed. Let's take a look at this. Here we have an inscribed angle A, and if we were to rotate it, so it's going to be half. It's going to be half of this arc. If I keep sliding it, let's say A is moving, 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 and it becomes what we call tangent, it is still half of this arc. So tangents will always be half of the arc that they intercept as well. So angle BAC will be half. So angle BAC will be equal to half of arc BC, just like it was over here. So that's what happens when it turns into a tangent. So tangents are also half. And look at, they actually write that as well. So that's your last theorem that you're going to need for this lesson. There's a lot of theorem. There was a lot of explaining. And you're probably like, okay, I'm a little bit confused, but we're going to go and we're going to answer a couple of questions. And hopefully that clears up any questions that you might have. It's nice to see it with numbers. So here's our first example. There's a lot going on with it. But I'm not even going to find the values of A and B. Okay. Well, here we have A, and I'm looking at it and I go, okay, A, well, let's see what A has. A is this arc right here. And I have 2 options. I can backtrack almost like a cone with ice cream here. It's almost like a cone with ice cream, where A is the ice cream part. And the 2 lines that are straight are the cone. So look, yeah, I can do that, or I can look back this way. So I really have a couple options. But notice the second option doesn't bring me all the way up to T. See how it fails to bring me up to T. So I can't, this isn't a good option to work with. So I'm going to erase this one. And now I see that angle PQT is the only angle I can focus on. So angle PQT is the inscribed angle. So arc PT is the intercepted arc. So what I need to do is I need to say that the measure of 2 measures of angle PQT is going to be equal to the arc PT. So I'm going to double it. So what I'm going to do is do 2 times 60 degrees is equal to arc, the measure of arc PT. So 2 of these is measure of arc PT. So the measure of arc PT is going to be equal to 120 degrees, making A equal to 120 degrees. So A equals 120 degrees. And now looking at B, now that I know that A is 120 degrees, I can find B. So I'm going to backtrack with B. I'm going to say B is equal to this right here, this intercepted arc, and then right there. So PTS is the arc in question. Well, PTS, the measure of arc PTS is a total measure of arc PTS is a total of 120 and 30 degrees. So the measure of arc. My apologies. Measure of arc PTS. So measure of arc PTS is going to be equal to 150 total degrees. Now what I need to do is I need to work backwards. So instead of multiplying this angle by 2, because I'm given the arc, I'm going to have to find half of it. So the measure of angle PRS is equal to half the measure of arc PTS. So the measure of angle PRS is equal to half of 150. So the measure of angle PRS, yikes. Measure of angle PRS is 75 degrees. And because PRS is equal to B, then we're going to say B equals 75 degrees. All right. And I'm going to bring this over here. So those are my answers. All right, they want me to find one more thing. So RS is 60 degrees. RS is 60. Wow, okay. So this is really getting more complicated, but I'm going to put 60 degrees right here. And now I'm going to do this last one. It wants me to know, let me erase some of these things. Wait, do I want to leave it for the notes? No, yeah, it's going to get too confusing now. The last one is going to be, it wants me to find PQR. So in this case, here's PQR. Think about all the intercepted arc. It's all of this right here. So what I need to do is add 120, 30, and 60. So I'm going to say, I'm going to do 120 plus 30 plus 60. And that's equal to 210 degrees, right? 12, 13, 14, 15, 21. Yeah, 210 degrees. So the measure of angle PQR is going to be half of arc let's call it PSR. So measure of angle PQR is half of 210 degrees, which is measure of angle PQR equals, it's 105 degrees. So the measure of angle PQR is 105 degrees. All right. Next, here are the corollaries questions. So you'll notice in this first one, we have a inscribed angle 1, but notice that you have a diameter as well. The textbook will give you these numbers, so you don't really need them. What we know is that this whole arc is 180 degrees. So when it's inscribed, we are going to have a right angle. So the measure of angle 1 is equal to half of 180, which is 90 degrees. Again, that occurs because it's inscribing a semicircle, and which is 180, so half of 180 is 90. Number 2 is using a corollary. So let's think about this one. If this is 38, then the arc it intercepts will be double that. So 38 times 2 is 76 degrees. And then what we have to do is work backwards to find angle 2. Well, that's going to be half of 76. So 76, whoa, what happened there? I'm not paying attention. So now we're going to do 76 divided by 2. And it's going to be 38. Ah, yes, because they have to be congruent, right? So 38 degrees. They intercept the same arc. Why did the textbook put that number 70 there? No idea. Probably just to try to confuse you. You don't need it. Just use your corollaries, and you'll know quickly what the missing measurement is. All right. We have, this is really cool. We have, and not only is this an inscribed quadrilateral, which we know have opposite angles that add up to 180 degrees, but it also looks like there's a diameter here. So I can quickly say that the measure of angle 1 is equal to 90 degrees, because that is inscribing a semicircle. It's intercepting the arc of a semicircle. So the measure of angle 3 is also 90 degrees. Not only because it's a semicircle, but also because it's collectively they have to measure of angle 1 plus the measure of angle 3 has to add up to 180 degrees. Now, can you find the other arcs? You can. There might be an easier way to do this, though. I'm looking and I see right away that angle 4 is composed of both of those arcs. And I know that 60 plus 80 is 140 degrees. So 140, if I find half of that, I'm going to get 70. So angle 4, I can quickly find out is 70 degrees. And lastly, if I want to find angle 2, yes, I can do algebra. I can do 180 take away 60 to find out, this arc right here is 120. And I can also do 180 take away 80 to find out that's 100. But I also know that 70 plus the measure of angle 2 has to add up to 180. So I'm just going to say 180 take away 70 is 110. So the measure of angle 2 has to be equal to 110 degrees. Again, there's so many ways to answer this question, but I just think the easiest one is what we just did by looking across and going, we have 2 values there. Might as well just add them together and find half of them. But yeah, so the measure of angle 2 then is 110 degrees. All right, again, you could have found this and then found half of it, but you didn't need to. All right, so now we're done with the lesson. I'm going to look through. If I think there's something that you can't answer, then I'll answer it. It looks like you should be able to answer 1, 2, 3, and 4, 5, 6, 7, and 8. 5, 6, 7 look reasonable. I would, when you do number 7, do 360, take away 82, take away 60. And what you'll find for number 7, let's see, 360, 300, 218. That is angle A. All I did was I took the whole degree measure around the circle. Think about this whole degree, that's 360. Take away what you know, which is 60 and 82. And then that will give you the rest of the arc measure. Okay? Yeah, that one. Now you should be able to solve for B. You know what? Let's just solve for B, seeing as we're already there. So A is 218 degrees, and then B is going to be half of that. So it's going to be 109 degrees. All right. So that one was probably a little bit trickier, but you have to figure out what you can solve for, which is A degrees. These are a little bit complicated. You know what? This one, yeah, these are going to take you a little while, but I think you can get it. There was one I remember that's really tough for students. Let me try to find it. 11 is easy, 12 is easy, 13, 14. Oh, this one right here, number 8. Sometimes students struggle with this one. So B, the measure of angle B is going to be equal to 30 degrees because it's going to be half of the 60-degree arc it intercepts. And then the measure of angle A is going to be equal to 54 degrees. The reason being, again, it's half of what it intercepts. So here's A, it intercepts that arc. Then here's B, it intercepts this arc. And then C is a little bit hard to find, but think about it. It's a vertical angle, all right? So if we have A is 54, A is 54 degrees. Let me try. If A is 54 degrees and B is 30 degrees, what I can find now is what's left over. So I'm going to do 54 plus 30, or well, I can take that away. Yeah, so that's 84. So I'm going to do 180, take away 84 is 96 degrees. So this angle here is 96 degrees. And because they're vertical, C is also equal to 96 degrees. So that one involved using a skill all the way back from September probably, which is the vertical angle theorem. And knowing that the triangle angle sum theorem, that the triangle adds up to 180. So I think at this point, that was the question that most students normally have. So that's good. I'll answer any other questions in the Google Live Meet or in individual office hours. All right, so don't forget, you're going to do exercise 12-3 for the notes and for the worksheet so that you're prepared for the tests that will be on this. All right, and That does it for 12.3.